We've been doing quite a bit with polynomial analysis, and we've discussed a worksheet of how you can go through the steps of analyzing and graphing a polynomial, but we really haven't talked about what happens when you have imaginary zeros of the polynomial. So I want to take a look at one polynomial, go through the entire worksheet and all of its steps, and then discuss how you can find all the zeros and what to do if any of your zeros happen to be imaginary. So here's my polynomial. It's a 5-term polynomial, and of course the first thing you'll want to do is to determine how many zeros the polynomial has. Remember that deals with the degree of the polynomial. So my polynomial will have 4 zeros. There are 4 values of x that make p of x equal to 0. Now those four numbers, they might all be real. Some of them might be real, while some imaginary. They might be rational. They might be irrational. We really just don't know. But we're going to have 4 values of x that make p of x 0. Next, let's look at the end behavior of this polynomial. So not only do we look at its degree, which is even, but we also look at the coefficient of that leading term, which happens to be positive. So with a positive leading coefficient and an even exponent, our function values approach infinity as x approaches infinity, as well as approaching infinity when x approaches negative infinity. So basically, for both directions of our domain, this function is going up. Next, to find the y-intercept, we're looking for the place on the function, the place where our function crosses the y-axis. So, of course, that's where the x-coordinate is 0. We're literally plugging 0 in for x, and that gives us the value of our constant term. So this function crosses the y-axis at 0, -1. Part D, let's narrow down the list of possible zeros. First of all, let's figure out how many of the zeros might be positive and real. And to do that, we'll look at the sign changes in p of x using what's called Descartes' rule. So the signs of p of x are positive, positive, negative, negative, and negative are the signs of all the terms. And reading from left to right, these terms' signs change only once. So that means that this polynomial is definitely going to have one positive real 0. This function will cross the right side of the x-axis only one time. Descartes' law of signs states at this point that you should continually subtract 2 until you reach 0 or 1. Well, we're already at 1, so we're not going to be subtracting any 2's from this one. Let's go on and look at the possible numbers of negative real zeros. And to do that, we'll find the sign changes in p of negative x. So let's see, when I substitute negative x in for x and p of x, my first sign will be positive, my second sign will be negative, my third sign stays negative, my fourth sign becomes positive, and my fifth sign is constant, so it'll stay negative. Reading from left to right, there's a change, and then it doesn't change from negative to negative. There's another change, and then there's still another change. So that means that I've got possibly 3 positive real zeros. Maybe not positive, sorry, negative. Not positive. I'm trying to analyze the numbers of possible negative real zeros. So I might have 3 negative real zeros. Maybe this function crosses the negative side of the x-axis 3 times. Maybe it bounces once and crosses through again. Maybe it only crosses through, and all 3 of the zeros that are negative are the same number. These are all possible things that could happen here. And then we subtract 2 from this number until we reach 0 or 1. So another possibility is that we might have only 1 negative real zero. Okay, so what could happen? So far, I've got to have 1 positive real zero. Well, if I've only got 1 negative real zero, if that's the case after I continue my analysis, then the other 2 zeros would have to be imaginary. If I've got this 1 positive real zero with 3 negative real zeros, then I don't have any imaginary zeros because I've only got 4 total. So this kind of gives me an idea now as I move on to my next step. It gives me an idea of where I will start to find the actual values of these real zeros. I'll do that in the next video. This one's getting a little bit long, so I'll stop it here, and then we can continue the worksheet in the next video.